Oliver, come.
We were supposed to make a triangle out of 3 skipping ropes and then split the triangle in half with another skipping rope, which represents the midpoint theorem.
Hey, welcome back to Beard Squid. In this video, we're going to be learning about the midpoint theorem. Now let's jump into class and see what the students got up to. Now students made triangles on the floor of the classroom and measured each of the lengths. They found the midpoints of 2 sides is equal to half of the base. So let's look at a few examples here. We can see that the line connecting the 2 midpoints is a half of the base of the triangle. So here you've got 47.5 and you can see that the base is 95, which is a half. Let's take a third example. Here we have 43.5 centimeters and we have 87, so a half of it. Right, let's use this example to show the theorem in action, and let's do a question. So here's our triangle, and what we're going to prove is the midpoint theorem. So let's just get rid of that for a bit and redraw that triangle. The theorem states that the line joining the midpoints of 2 sides of a triangle is parallel to the third side and half its length. This theorem, called the midpoint theorem, gives us the following information. We have one midpoint, which let's say is this one here, and then the second midpoint, of course, this midpoint here. In fact, if we label this diagram A, B, and C, we can say M is the midpoint of AB, and we can say N is the midpoint of AC. What we deduce from that is that we can deduce that the lines are parallel. MN is parallel to BC and it's half its length. So in class, one group of students made a triangle with a base of 95 centimeters and the line joining the midpoints was 47.5, which is a half of that. So let's do a question with the midpoint theorem. So it says M and N are the midpoints of AB and AC respectively. Find the length of MN, the size of the angle ANM, and then finally the area of the triangle ANM. So here's the following triangle. The first thing that we know is that we're given that a midpoint and a midpoint. So we're given 2 midpoints. So what we're going to do is we're going to deduce that the 2 lines are parallel. MN is parallel to BC and that MN is half of BC using the midpoint theorem. So since M is the midpoint of AB and since N is the midpoint of AC, as shown in the diagram, then we know that MN is parallel to BC and half its length due to the midpoint theorem. So therefore we can say that MN, this length here, is a half of BC. And since BC is 11 centimeters, then MN is going to be 5.5 centimeters. Okay, so moving on to part B, we're finding the size of the angle ANM. So this angle here, A, N, and M. So the first thing that we can consider is since MN is parallel to BC, we know that the angle AMN is corresponding. So this angle here, okay, AMN, is corresponding to ABC. Therefore, the angle AMN is 90 degrees. So we draw a little 90 degrees here. Now, the second rule that we're going to be using is since interior angles of a triangle add up to 180 degrees, therefore, ANM is going to equal to 180 minus the 54 plus the 90. Now, they already gave us 54 here, so 54 plus this 90 plus whatever this is should add up to 180 degrees. So 180 minus 144 is going to give us 36 degrees. So the angle ANM is 36 degrees. And so finally, we're going to work out the area of the triangle ANM. So this triangle here, ANM, this small triangle. Since we know that M is the midpoint of AB and that N is the midpoint of AC, we know that MN is parallel to BC and half its length, i.e. we're using the midpoint theorem. So in terms of this triangle here, let's redraw it again. We have the following lengths. Remember, this M is the midpoint of AB. So we have 4 centimeters for AM. And we also know that MN is half the length of BC due to the midpoint theorem. That's what we worked out in part A. which is 5.5. So the area of a triangle is base times height divided by 2. So therefore, 5.5 times 4 divided by 2 is going to give us 22 divided by 2. And the area of the triangle A&M is going to be 11 centimeters squared. As always, thank you for watching. If you found the video helpful, then drop me a like and consider subscribing for more math videos, and I see you in the next one.